Good afternoon, everyone. Good afternoon, Dalit ma'am. Good afternoon, Ravinder sir, and all the students. Okay, so let us start with this question that we were doing yesterday. Area of track. I have told you that in this area of track, how to calculate area of outer rectangle minus area of inner rectangle and area of outer semicircle minus area of inner semicircle. Then we'll be able to get this blue colored area. That is the area of track. So we have written the formula. Area of outer rectangle minus area of inner rectangle. Then 2 into area of outer semicircle minus area of inner semicircle. So area of outer rectangle, that is length into breadth. So 106 is the length and 80 is the breadth of outer rectangle. Then 106 is the length and 60 is the breadth of inner rectangle. So this is the first part. Then second part, twice of area of outer semicircle minus area of inner semicircle. Outer semicircle pi capital R square by 2, then minus pi small r square by 2. Here we can take 106 common, 80 minus 60, then plus 2. Here we can take pi by 2 common, and it will left with r square minus r square. 2 and 2 cancels out. So it is 106 multiplied by 20 plus pi, that is 22 by 7. Then r, capital R square minus small r square. Capital R is 40, small r is 30. 40 square minus 30 square. So it is 0, 1, 2, 2120 plus 22 by 7. 1600 minus 900, that is 700. This and this cancels out. So it is 2120 plus 2200 is 4320 meter square. This is the answer. Good, Ankur. Ankur has already done this. Okay. Note it down. So this part which was left yesterday is completed now. Okay, so moving on to the next question for today. Question number 9. AB and CD are two diameters. See this, AB and CD, these are the two diameters of this circle. The bigger circle with center O, and O is the center. And these are the diameters. It means these all are acting as radius, and these all sides are equal. OD, OB, OA, and OC, radii of the same circle. If OA is 7, then OB will be 7, OC will be 7, and OD will also be 7. So writing here, OA is equal to 7 centimeter. Therefore, OA, OB, OC, OD all are 7 centimeter each, radii of same circle. After this, we have to find the area of shaded region. Now, if we come to shaded region, then this is a circle which is shaded. So we can take out the area of this circle, where the diameter of this circle is 7. As we know that OD is 7, so radius will be 7 by 2. So we can take out the area of this circle separately. Then after that, how we can take out this? Now, this can be calculated as area of the semicircle, area of the semicircle. You can see like this, area of this semicircle minus area of this triangle. Then we'll get this shaded portion. Okay, so write area of shaded region. First is what we have to write, area of circle with diameter OD. Which circle we are talking about? In the circle which has diameter OD plus area of semicircle with semicircle ACB minus area of triangle ACB. Now area of circle pi r square plus area of semicircle, that is pi capital R square by 2 minus area of triangle is half into base into height. See, if we'll talk about this semicircle, then it has different radius as compared to this circle. This circle has radius 7 by 2, and this semicircle has radius 7, because OA, OB, and OC are representing the radius of this semicircle, that is 7. So that's why we have represented by different R's here. Okay. Now 22 by 7 into 7 by 2 into 7 by 2 plus 22 by 7 into 7 by this 2, and half into base. What is the base here? AB, and height is OC. And height is OC. Now cut them, cancels out. So 77 by 2 plus it is 77 minus half into base is 14 and height is 7. 7 sevens are 49. So 77 minus 49 and there is 38.5. Subtract 66.5 centimeter square. So this is the answer. Done. Is it clear to all? Next question. The area of equilateral triangle is given. This is an equilateral triangle ABC where the area is 17320.5 centimeter square. So area of equilateral triangle ABC is 17320.5. Okay, centimeter square. Area of equilateral triangle, the formula is root 3 by 4 into side square. That is 17320.5. Now, what is the value of root 3 given here? The same we have to apply if it is given in question. 1.73205 by 4 into a square is equal to 17320.5. A square is equal to 17320.5 into 4 upon 1.73205. Point removed. Point removed. Cancels out. That is a square is equal to 40,000 and 40,000 is the square of 200. So the side is 200 centimeter. So the side of this equilateral triangle is 200. So each of the side is 200. Why I have calculated side? Because it is written here that from the vertex, you can take any of the vertex. Suppose this is the vertex A. From vertex, our circle is drawn, and from the another vertex and another vertices, circles are drawn. And a circle is drawn with radius half the length of the side of the triangle. So that's why if side of the triangle is 200 centimeter, then radius of each circle is half of the side, that is 100 centimeter. Okay, and we have to find the area of shaded region. Shaded region is this much only. So area of triangle minus area of these three sectors, the white sectors. Do not look at the circles outside it. Just see the sector inside the triangle. So from the triangle, we have to subtract these three sectors to get this shaded region. And angle of the sector is 60 degree as it is equilateral triangle. Since ABC is equilateral triangle, therefore theta will be considered as 60 degree according to the formula. So area of shaded region is equals to area of triangle ABC minus 3 into area of sector. So area of triangle half into base into height. No, there is no need to apply this formula as area is already given, or any other formula also. See, this area is already given to us 17320.5. So we'll write here 17320.5 minus 3 into area of sector, that is pi r square theta upon 360. This and this cancels out. So 17320.5 minus pi we have to use 3.14. 3.14 into r is 100 square into theta is 60 upon 120. Cancels out with 2 also, we can cancel this. 17320.5 minus 15700.52061. 1620.5 centimeter square is the left out area. Is it clear? Out of area of triangle, we have subtracted the area of three sectors. So we have multiplied with 3 with the area of sector. We have 2 continuous lectures today, 12 to 12:40, then 1 to 1:40. As these chapters are taking time, so that's why I am taking some extra lectures every week. And this week there can be more extra lectures. You'll get to know by tomorrow if there will be any other extra lecture this week. Now, the next question. Question number 11. On a square handkerchief, 9 circular designs, each of radius 7 centimeter are made. So these are 9 circular designs, each of radius 7 centimeter. So one circle is having a radius of 7 centimeter. Then diameter will be how much? Diameter will be 14. Then diameter of this will also be 14. Diameter of this will also be 14. See, 7 centimeter radius, then again 7 centimeter radius. So diameter is 14. Then again 7 centimeter radius, then again 7 centimeter radius. So diameter is 14. Again here also 7 centimeter radius, and again 7 centimeter radius. So the side of the square will be 42 centimeter in this way. So we have to think a little deep that the radius is given 7 centimeter, then again 7, then 7, 7, 7, 7. So that's why the diameters are 14, 14, 14, and the height of the square is 42 centimeter. Clear? In the same way, so the side of square is 42 centimeter. Find the area of the remaining portion of the handkerchief. It means they're talking about this white left out area in between, regardless of this design. See, area of square minus area of these 9 designs, then we'll be able to get the area which is the remaining portion in the handkerchief. Right, first of all, the radius given, radius of each circular design, that is 7 centimeter, and side of square, yes, correct, area of square minus area of 9, not 9 sectors, it is 9 circles. So side of square is 6 multiplied by 7, because there are 6 radii. See this 1, 2, 3, 4, 5, 6, 6 radius we have joined. So 6 into 7, that is 42 centimeter. Then area of remaining portion is equal to area of square minus 9 into area of circle. Area of square is side into side minus 9 into area of circle, that is pi r square. Side into side, 42 into 42 minus 9 into 22 by 7 into 7 into 7, 7, 7 cancels out. 42 square will be 8 minus 34, 1764 minus 22 into 9 into 7 will be 1386. So subtracting them, 378 centimeter square is the remaining portion on the handkerchief. Now the next question. Just wait for a minute. Now, question number 12. This chapter will get complete today with the help of the next lecture. So this question let us do now. In this figure, a OACB is a quadrant of a circle with center O. Center is O, and this is acting as quadrant. Let me tell you how. If this is the center, then obviously this is the circle, where this is one part of that circle. So this is a quadrant of that circle. Circle was very badly made. Still better. So this is the quadrant of circle. Now I hope you are clear with this figure. So OACB is a quadrant of a circle with radius 3.5. So this is also 3.5, and this way also it is 3.5. And OD is 2. So this OD is 2. And as this is a quadrant, so obviously here it is making 90 degree, because quadrant is possible only if the theta is 90. Find the area of quadrant. First of all, we have to find the area of this quadrant OACB. Then we have to find the area of the shaded region. Area of shaded region can be calculated as area of quadrant minus area of this triangle. Area of quadrant minus area of quadrant minus area of this triangle. Okay, then starting with the solution of this. Like radius of quadrant of circle is 3.5 centimeter. Then OD is 2 centimeter. Fine. In first part, area of quadrant is separately asked. So area of quadrant OACB, area of quadrant pi r square by 4. So pi 22 by 7 into r, that is 3.5 into 3.5 by 4. Remove the points, you'll get 10 into 10 by 7, 5 to 11, 5 2 5 7 5 2, that is 77 by 8 centimeter square. So this is the first part. Now second, area of shaded region is equals to area of quadrant minus area of triangle BOD. So area of quadrant we have calculated 77 by 8 minus area of this triangle BOD, half into base into height, so which includes the base 3.5 and height 2, which is given. 5 7s are 5 2s are. So taking LCM, 77 minus 4 7 are 28, 49 by 8 centimeter square. This is the full solution. Note it down. Okay. Yeah, it was muted. See this in this question, no? There is a quadrant OPBQ, and quadrant I have shown by making this circle, and O is the center, and OA is given 20 centimeter. Obviously, this is not the radius of this quadrant because the radius is OP and OQ. So how we can calculate the radius if only this is given? With the help of this, how you can calculate the radius of this circle? or of this quadrant. See this? Can I say this, that this is the radius of the circle? From the center to the circle, this is the radius of the circle, or we can say that this is the radius of this quadrant also. So with the help, this line will help us to calculate the radius. How? Not by Pythagoras. That is not required. Yeah, by Pythagoras we can do that. Ankur is saying, sir, Pythagoras theorem. That is fine. But look, if you know the formula directly, you can apply. Yeah, Pythagoras is universal. We can apply here easily that it is 90 degree. It is a square. So this is also 20. This is 20. This is 20. So we can calculate this hypotenuse. That is correct. And if you know the formula directly, you can apply the formula also. Right. First of all, OA, that is the side of square, is given 20 centimeter. And diagonal of square, this is the diagonal of square. Diagonal of square is calculated by the formula √2 multiplied by side, or you can say √2 multiplied by the side represented by letter A. So √2 multiplied by 20, where is 20 √2 centimeter. Therefore, radius of quadrant is also 20 √2 centimeter. Okay, the lecture is over. Pi in the next lecture will continue from here. Okay.